let's talk about what a scale is. So if you think about a scale drawing, if we wanted to make a scale drawing of this room, we would not be able to fit it on a sheet of paper unless we shrunk it down and reduced it so that it is a similar size to the original, okay? So that's all a scale drawing is. Usually it is shrunken down to match the dimensions of a room, and they'll provide a key. They might say that 1 inch, if I can get my pencil started here. So they might provide a key. So at the top you can write the word key. And on the scale drawing, they might say that 1 inch is equal to, let's say it's a map, is equal to 5 miles. Now we know that 1 inch is not equal to 5 miles. So that is not what that means. A key on a map just is giving this what's called the scale. Sometimes you'll even see it written with 2 little dots. That's also showing a ratio or a scale. That does not mean we know that 1 inch is not equal to 5 miles, but it's just allowing us to know how they are interpreting the scale. So let's say this room, I thought we did before, that it was roughly 30 by 30. So 30 feet by 30 feet. So on our paper, we might say that an inch is 5 feet. And if we made a picture that was 6 inches, 6 times 5 is 30. So we could do that, okay? So the scale is what the key is showing. It is the ratio of the model size to the actual size. Sometimes it's written, so let's say the scale was 1 to 5. Sometimes they'll use the word 2. Sometimes they'll use 2 dots. Sometimes they will write it as a fraction. So you can see a scale written a variety of ways, but you need to interpret what that means. So know that all those things mean the exact same information, okay? So what we're going to try to do is we're going to try to talk about finding what that fraction, that ratio, or that proportion is, then solving it and setting up the proportion. Yesterday on that page, that first page, you guys were doing proportions very well. So it's just now, can we interpret the word problem and can we make it into a proportion, okay? So basically, we need to find what those whole pieces are or that ratio, and then we can either divide it or we can do that cross multiplication. So let's take a look at problem number 1. Now they've set it up, but let's read this problem here. They're kind of giving us a guide so that we can jump to number 2. Okay, so let's read number 1. It says a map scale is 1 inch is 30 miles. So that's 1 to 30. We can write it as 1 dot dot 30, 1 over 30, or 1 with the word 230. All 3 of those things are equal. Now it says the distance between 2 cities is 45 miles. What is the distance between the cities on the map? Look what they've done. This side here is our scale. Okay, so you can see 1 inch is 30 miles. So that means you have to have inches on the top on this side, and it has to be miles on the bottom on this side. So you just, as long as you make it that these units match and they're across from each other exactly perfectly, if I use the scale on top and the real actual miles on the bottom, then I have to do it on both sides. And as long as you set it up like that, then you can cross multiply. So look what they did. What they did is a little different than what we did. So could you please add a little note right here? We can put a little note to ourselves that we're going to cross multiply, because I think that's the most effective way to solve a proportion. So let's watch what they did. Well, they kind of cross multiplied, didn't they? Okay, so let's show you what they did. That's the top piece right here. I'm going to highlight it in yellow. So they did 1 times 45, and 30 times x. So they cross multiply. That's what the top is showing. And then what were we doing with that coefficient that we were having that was stuck to our variable? That's when we divided by both sides. So then they divided it. And then they were able to solve it. But do you see this piece right here? Are we answering the question if we just say 1.5? No. Always go back and read this question right here one more time. Anytime you're doing a math word problem, read the question one more time and have you formatted your answer in a way that makes sense. It says, what is the distance between the cities on the map? Distance is, it needs a unit. The map is showing inches. We should write the word inches, okay? So any questions about how they solved that first one? Okay, so now let's do the exact same thing and let's fill it in as we go on number 2. So everybody do number 2 with me, okay? It says a scale drawing has a scale of 2 centimeters to 15 meters. If the length of something on the drawing is 12 centimeters, what is the actual length? So the first thing you write is your scale. So you write 2 centimeters over 15 meters. So we're going to write it as a fraction. So that's the first thing you do. Now you notice I put centimeters on top. I put meters on the bottom. So put your equals. Put your fraction bar. And then let's just put a little cm and m to remind us where we have to fill it in. Okay, now let's read this portion right here. It says, if the length of something on the drawing is 12 centimeters. So should the 12 go on top or should the 12 go on the bottom on that right side? Tommy. Top, right? Okay, it says centimeters. So let's put our 12 here. Okay, and so we don't know what the actual length is. That's in meters, so put your X there. So that's as easy as you got to do. However the proportion is set up on one side, make sure you're consistent on the other side, and then you're going to get these right. Okay, so now it's a matter of cross multiplying just like we did yesterday. That's why we did that first. So let's cross multiply. 2 times x is 2x. And this is going to be 15 times 12. Now I'm going to write that there just to remind you how we did that. So if you didn't grab a calculator today, in a second, you can grab a calculator. I'll do it for you right now. 15 times 12 is 180. So 2x equals 180. Now in an algebra class, if a 2 and an x are touching each other, that means they're going to multiply. So we have to undo that multiplication. The opposite of multiplication is divide. So that's what they did over here when they divided off the 30. Here we got to divide off the 2. So let's divide both sides by 2. If we divide both sides by 2, the great thing here is those are going to cancel. 180 divided by 2 is 90. So our answer is 90. But let's go back and look at how they asked the question. The question that they're asking is, what is the actual length?
90 meters.
There you go. Make sure you have that unit. So this is 90 meters. And if you just put the little m, that's fine. If you write the word meters, that's fine. And then think about your question. If 2 centimeters is equal to 15 and we have 12 centimeters, 90 seems a reasonable answer. Always, kind of logically, did that make sense how I got that? Do we have any questions about 1 or 2? Okay, let's do another one. Let's do number 3. It says the scale on a blueprint of a home is 1 inches 4 feet. The actual length of the family room is 26 feet. What is the blueprint length? So let's talk about what we do. Remember, our first step was to write our proportion. Okay, so we know 1 inch is 4 feet. The scale, the blueprint is the inches. The real length is 4 feet. So we know that this is the scale and this is the real. And the units match. It says the actual length of the family room is 26 feet. So where does that 26 go? Does it go on the top or on the bottom? Where does our 26? It goes on the bottom, right? Okay, so our 26 feet goes here. We don't know this inches. You can put X inches or just X, that's fine. And then the second thing we're going to do is we're going to solve the math. So now we're going to cross multiply. So we're going to multiply 1 times 26 and 4 times X. Now we can't really multiply 4 times X because we really don't know what X is. So just write 4X. 1 times 26 is 26. 4 times X, just write 4X. If you put 4 with that little multiplication dot between them, that's okay. Okay. And then how do we get that X by itself? Divide by 4. So we're going to divide by 4. And because this is a real life application, getting that decimal is a good idea. Rounding maybe to the nearest tenth is probably a good idea. This one rounds to the nearest tenth automatically, and we get 6.5. And then our last thing is answer the question. If I came up to you and said, yeah, it's 6.5, that doesn't mean anything, right? It's 6.5 what? So always read that question one more time. The thing that has a question on it is going to point you into how to write your answer. It says, what is the blueprint length? So it's 6.5 what on the blueprint? 6.5 inches or feet? Inches. So make sure you write 6.5 inches. Okay? Now I want to do 4. Well, maybe 4, we might just keep on this page and then the next page is you can do yourself. But let's take a look at 4. The reason I want to do 4 is because it's got this fraction that would be inside of a fraction, which is weird. I'm going to show you yes. So if it's a nice decimal, like 1/2 is the decimal 0.5, we can definitely turn it into I'm going to show you 2 different ways. Okay. It says the scale on a drawing is 1/2 inch to 6 foot. So we set up our proportion. You can do 1/2 and 6. This is inches, this is feet. Since we are going to cross multiply, you can leave it that way. Okay. Another alternative is to make it 0.5 over 6. That will also work. Okay. So math is kind of interesting in the fact that sometimes there are multiple ways to get to the same place. And I'm okay with that, and I know that, and so I will give it to you whether you set it up the first way or the second way. Doesn't matter. Okay. Now it says the distance on the drawing, which is that inches, is 1.5 inches. What is the real distance? Now if we keep it fractional, does the 1.5 go on the top or the bottom? Should the 1.5 go on the top? It should go on the top, right? Because of the fact that it is the scale. It is inches. They match. So the real distance is in the bottom. That's your X. Now we can keep the pattern going on the right side with decimals. 1.5 is 1.5. There's a button on the calculator. You might not realize it. Here's my giant calculator. Mine's blue, but it's the same thing. This ABC button, if you put in 1, hit the ABC button, then 2, no, 1 for 1 and 1/2. 1 ABC button, 1 ABC button, 2. So 1 and 1/2. If you hit that, see this button right here that says fraction to decimal? If you hit second in this one, it will make it into the 1.5. So if you are unsure how to make 1.5 into a decimal, just use that ABC button. And if you haven't used it before, just let me know. We can use it together. So you can use either the proportion you see on the left or the proportion on the right. It doesn't matter. Either's going to work. Here you have to use fractions. So I think sometimes that can be a little bit weird, especially a lot of kids don't care for fractions. That's just a common thing. So if you like the decimals, go ahead and solve it. No matter how you do it here, I'm just going to keep on the right with the decimals. 0.5 times X and 1.5 times 6. 1.5 times 6 is nice. It is 9, so let's make that a 9. Here it would be 1/2 of X equals 6 times 1.5. So it does look a little funky that way. Okay. If we continue on the right, what number do we have to divide off? Yeah, you got to divide by that 0.5, that 1/2. And so if we divide it off the 0.5, we get 18. Now, have we answered the question in the format that we should, that we have not? How should we write our answer? 18, what is the real distance? 18 feet. So make sure you put 18 feet. Okay. Now, the reason I didn't want to stop, I want to do 5 and 6, because see how it's saying, what is the scale? Okay. So I would like to talk about how to find a scale if it hasn't been given to you. So let's take a look and do 5 and 6 together. Okay. It says 2 cities are 1,750 miles apart. On a map, the cities are only 5 inches apart. What is the scale on the map? So usually, see how this is a really important thing. If you want to circle that, you should put the model or the whether it's a model or a blueprint, whatever it is, should go on top, and the actual should go on the bottom. So that's what you want to set up every single time you do these. So you see how they set up 5 inches was to 1,750 miles. But let's talk about how you got that. If in the ABC button, if you hit 5, then you hit the ABC button, it'll give you a little, I'm trying to see what, if you hit the ABC button, there's a little notch. That's supposed to be the fraction bar, okay? And then if you hit 1750, and then if you hit equals, it is going to show on your calculator 1 over 350. So if you want to go grab a calculator at this time, I want you to put into the calculator 5, hit the ABC button, 1750, and make sure your calculator reads that 1 over 350. So grab yourself a calculator and make sure you understand that the calculator will reduce a fraction for you. Now let's talk about how they actually got that mathematically. Okay? What do we have to divide 5 by to turn it into 1? What do you got to divide 5 by to turn it into 1? 5, right? If a number ends in a 5 or a 0, we know it's divisible by 5. So technically, all they did to get that reduced version mathematically was to divide the top and bottom by the common factor of 5. That's all they did. Now, the ABC button on the calculator does that. So if you use the division button instead, it's going to give you a decimal. But if you use the 5 ABC button, 1750, and hit equals, it will give you the reduced fraction every time. So that's a good one to use in this particular case, okay? So remember, the proportion or the fraction portion doesn't show the scale like you would see usually on a map. So let's get in the habit of writing it with the 2 little dots. So this would be your model, 1 inch. This would be the actual miles between the cities, or on the map, 1 inch is equal to 350 miles, okay? Now let's do it ourselves. Let's do number 6 together. It says a 75-foot statue of Mr. Seidel stands outside. A miniature replica is just 10 inches tall. What is the scale? So remember, we're going to do model over actual. So the model is 10 inches. The scale is 75 feet. And then you just got to reduce. Both of those are divisible by 5. If you use that ABC button, can somebody tell me what their screen says if you do the ABC button? What'd you get? If you use the ABC button and you put in 10 over 75, what did you say? Did you do it? Say it again a little louder. 2 over 15. Now, I don't want you to stop there. I want you to write it as a scale with the 2 little dots. So you're going to go 2 inches and then the 2 little dots. We say it 2 inches to 15, every 15 feet. So in your actual scale, make sure that you include the units. The first number should be your reduced model. Your second number should be the actual, okay? So make sure that you are writing it like that. Do we have any questions there? Okay. So we have some more examples. We're going to, let's do this page together. I keep saying we're not going to do it together, but let's do this page together. And then for the remainder of class, you can try 4 through 8. So let's do these example 1, 2, and 3. Okay? So we'll do these together, and then you'll have some time. Okay, so let's read this example 1. It says, according to the American Automobile Association, the overall cost of owning and operating a passenger vehicle averages $7,834 based on 15,000 miles of driving. So let's assume this is 20 years old or so. But anyway, okay. If the cost per mile is constant, about what would it cost to drive 12,000 miles? Okay, so see how it says cost per mile. They're actually giving us a hint of how to do it. So it's cost per mile or cost per mile. So our scale for this particular context is the cost to the miles, okay? So initially, let's set up our scale. So our cost was $7,834 for 15,000 miles, okay? Now, let's put that into a calculator so that we can get a scale that is reduced as much as possible. So 7,834, ABC button, 15,000, reduces down. Oh, it doesn't reduce down completely. Real great. Let's do it ourselves. 7,834 divided by 2. It just divides by 2. That's it, I think. Yeah, it just divides by 2. Okay, so if we divide the top by 2, you get 3,917. If you divide the bottom by 2, you get 7,500. So our scale is $3,917 per every 7,500 miles. Okay, so that's our scale. Okay. So now let's answer the question. Read the question again. It says, if the cost per mile, which we just found, $3,917 for every 7,500 miles, is constant, about what would the cost be to drive 12,000 miles? So we're going to set up 3,917 over 7,500 equals the cost, we don't know. The miles, we do know. Remember, this is miles, this is dollars. So we have to put the unknown, what we're trying to find, X on top, and the 12,000 miles on the bottom. So that's our proportion for this example. Now, we know how to solve proportions now. We practiced them yesterday. We've seen some today. We're just going to cross multiply. So we're going to get 3,917, and I'm just going to write it with a little dot between us, times 12,000 is 7,500 times X. Now, let's just leave it there for a minute, because in our calculator, 3,917 times 12,000 is a pretty big number.
Yeah, some 47 million.
Yeah, it's a gross number. So let's just leave it. What number are we going to divide by? What number do we have to divide off? So here's our proportion. How do we get the X by itself? What number are we dividing by? 7,500. So let's divide both sides by 7,500. So all you got to do in your calculator is put this exact thing. 3,917 times 12,000, get that big number, and then divide by 7,500. So you put in yours, I'll put in mine. We can check each other here, make sure that we get the same answer. Now, this is money. This is money. So it is customary to use 2 decimal places to show the cents. So in this case, the answer would be $6,267.20. Now, putting the dollar symbol there answers the question. So it gives you what you want. It answers the question, what is the cost? That would be $6,267.20 to drive 12,000 miles. Think about the fact that 15,000 miles cost us 7,000 something. So 12,000 miles should be less than 7,000. That's just a really good quick check that we were doing it right. Everybody good with that example? Okay, let's look at example 2. The typical scale for a house plan is 1/4 inch to a foot. If the width of a room on such a plan measures 3.5 inches, what is the actual width of the room? Okay. If you were to put into your calculator 1 divided by 4, what's the decimal for a fourth? 0.25. Let's write it as 0.25. Oh, did I not hit the actual save? This is Hot speaking. Hi. Yeah, no problem. Okay, bye. Jeanette, at the end of the class, you need to go see Mr. Chaberta. Okay, so now let's go to 3.5. We know the decimal for a half is 0.5, right? 0.5. But this is 3.5, so just throw that 3 in front of the 0.5, okay? So let's use the decimals only because they're really, really nice decimals. And let's set up our scale. Our scale is 1/4 inch to 1 foot, or 0.225 inches to 1 foot, okay? So on our model, it's 3.5 inches. So let's set up our proportion. So we would go 0.25 inches to 1 foot is the same as, where does that 3.5 go? Where does that 3.5 go? Does it go on the top of our fraction on the right side, or does it go on the bottom? It goes on the top, right? Because that inches has to line up, right? So our 3.5 goes here, and our feet, because that's the actual room is in feet, is our x, is our unknown, and that's where the x goes. We're going to solve it by cross multiplying. So we're going to multiply to solve it, okay? So 0.25 just gets stuck on the x, or you can put a little dot between it. And then 3.5 times 1 is nice because it's just 3.5. What do we divide by in order to solve that equation? We got to divide by that 0.25. Let's do that. So we would put in our calculator 3.5 divided by 0.25. What do we get as an answer? You got it. And what units would those be, Chase? Feet. So make sure you put that. And then go back. Did you answer the question? What is the actual width of the room? 14 feet sounds reasonable, right? So we've answered the question. Okay. Now let's go back to geometry class. Fun stuff, right? It says that these two figures are similar. That's what that little dot means. It means you could take and you could cut this out. You could throw it on like a copy machine and blow it up, and it would match this one. It's all the angles are congruent. All of the sides are in proportion. That's all that means. It can be set up to solve things with a proportion. That's what similar means. You saw how easy we did the proportions before. Do you see how this side, BC, and LM are kind of in the same location, same kind of shape, if you could imagine blowing up the little one so it could fit the size of the other? Look here, BC is in the middle, LM is in the middle, okay? So the scale that we could use, or the 5 and X kind of go together. Can anybody see another pair that goes together? 4 and 6, yep, BA, that's these two, goes with what? LK, right? So we're going to set up a proportion. First, let's do the scale factor. If we go from the little to the big, like they've said, A, B, C, D to K, L, M, N, it is 4 to 6. But 4 to 6, what can both of those numbers be divided by? 2. So let's divide them by 2. And so if we divide the top by 2, we get 2. Divide the bottom by 2, we get 3. The scale is 2 to 3. The scale is 2 to 3. Now it says find the value of x. So we know little to big. So this is our little one. This is A, B, C, D. And this is K, L, M, N. is 2 to 3. So now just go from little to big and to set up the right side. So that would be 5 over x. Okay, so let me show you again. We went from little to big to use the 4/6 or 2/3. If you use 4 over 6, it's going to work. And then you go 5 over x, little to big, little to big. It's about consistency. If you set it up little to big, you have to go little to big on both sides, or that's where you could fall off the rails. And now it's just a cross multiplication. So 2 times x is the same as 3 times 5, or 15. What number do we have to divide by? The 2. Let's divide by 2. Now, but divided by 2 is nice, because no matter what, it's going to give you a nice decimal, and we get 7.5. Now, the little side was 5, the big side was 7.5. That sounds reasonable, right? Because it's gotten bigger, so odds are we did it right. So just kind of checking that little thing. They didn't give us any kind of units. So here's one, there's not a real-life application. We don't need units. Make sense? Okay. So your job right now is to work on 4 through 8, and I hope, we'll see, but I think you should be able to get them done before the end of class. What time's this bell ring? 23? 33? Okay, so you got lots of time. Your job, please, is to finish these problems, and then I'm going to collect it at the end of class. Okay? So there you go. You do your thing, and if you need me, just raise your hand. I'll help you.